I'm going to start out this beginning of this video with kind of going a brief overview of what all this does. So, to begin with, we just have a simple point in the world which our line trace starts, and then a new one where the line trace ends. And we're using those as kind of the distance, so we have a starting point and an ending point, a line that runs between them. If that line hits anything, we will store that inside of hit results. Now, hit results has a lot of info in it, so we can just go through the list. So we have the hit actor, whatever component was hit, the distance that it took between the keep going here. We have the location and the normal of the blocking of the hit area. We have the bone name that was hit. We have a bunch of other information stored in here that gets filled. And this is very useful when you're doing certain things such as shooting, for example. Like a lot of games such as Squad, for example, yeah, they do have projectiles, but they also at the same time are using line traces to sweep for hits. So they're not using the projectile as it, at least as far as I'm concerned, as the method of getting the hit. Instead, what they're doing is on each frame, they have the location of the projectile, and then they shoot a line trace from the previous location of the previous frame to the location of the projectile on the next frame. So it's a line trace between the gaps because the projectile is going to be moving in big chunks when it's moving fast on each frame alone. So that's why a lot of people use line traces as their form of hit detection, because it's a lot more reliable, and you can detect whether or not it actually hits something in case of possibly having a missed hit because the projectile jumped and went too far past the hit, the player it was supposed to hit, between frames. And there's also an option inside of Unreal Engine by default to enable sweep results that kind of does something similar. I'm just not too familiar with it. Anyhow, we perform our line trace, fill up our hit result, in which case we compare the actor. So I want to go ahead and actually store this actor in a variable, so that way we can make use of it. So a actor hit actor equals hit result get actor. Now this will make it so it's only hit actor is only going to be valid, or this stuff's only going to be valid if hit actor is valid. Then we can just do hit actor get name, and that's all. So we want to check, we want to try to move the object. So what I'm going to do is try to attach the hit actor to ourselves. What we can do is hit actor, attach to component, and then we have the component that we want to attach to. In our case, a component is our static mesh or a skeletal mesh or some variation. So we're going to use our skeletal mesh, which is our first person mesh right here, our arms, as the component to attach to. So we're going to do it's mesh 1p. Then we have the transform or the attachment rules. So F attachment transform rules, : we're going to use snap to target, not including scale. And then the name of the socket we want to attach to. So this will cover some sockets. So F name is the type, and then socket name. So we're going to change socket name with a socket that we set inside of our mesh. So to do that, we go to our first person character mesh and load up the skeleton tree. And here we have a list of bone names that all correspond to different things, like so. So this is however it was set up in the modeling software such as Maya, Blender, 3ds Max, and so on. So if we scroll down, we want to set it at the root, or the pelvis better yet, because the pelvis is kind of the point at which we want the object to be. So we're going to create a socket on here and position it out in front of us so we can visually see it. I'm going to right click on pelvis, add socket, and rename this socket to attach socket. So I'm going to change socket name to attach socket. Now over here, let's go ahead and move it. Move it way out in front and up, about like so, and hit save. Now that we have that name set, Control S, and then Control Alt F11 to do a hot reload. And let's see what happens. Nothing, and nothing. Now, why is that happening? Well, these are physics objects, so they are movable and stuff like that, but they're set to simulate physics. So if I uncheck it on this guy, and I walk into it, nothing happens. But if I walk into this one, probably a little bit too heavy, but it pushes it around. So now when I press E on this one, I pick it up and I carry it with me, and it's kind of glitching me out a little bit, because if I walk forwards, it moves me backwards, and this is all because it has collision to it. So for example, if I go ahead and move that socket way out, just for example, it shouldn't do that because we're not going to have collisions forcing us back. So I press E, and here it is. I can just take it and I can whack crap with it. Hard as I want. And it's just gonna, something went flying. And that's how that's kind of going to work. So we have our object here, and that's how it gets attached. You can't attach an object that's simulating physics. When you pick it up, you would have to disable the physics simulation of it. We would want to do a check. So hit actor. Let's search for physics. I'm not looking at the right thing. I'm trying to think of what it would be called. Get root component. Is simulating physics. So here we can check and see whether or not it is actually simulating physics. And if it is, we want to disable that simulation and go from there. So let's do a test. So then we're just going to do, well, by default it already does name underscore none. So we're going to do a check here. So if it is simulating physics, we're going to print out a log. Is simulating physics. Save it, Control Alt F11, and see what happens. Now, when I press E on this guy, is simulating physics, and this one is not simulating physics. And it went over the wall. So that's where we can make our change. So if it's simulating physics, we want to go ahead and get our root component. I'm going to try to disable that. So we have some stuff related to physics. I'm trying to think of where it is that you go to actually disable physics. Let me think. It's not off the root component. Okay, so I went over and I looked on the wiki here, and to call set simulate physics, we have to get the primitive component. What we're going to do here is we're going to get the primitive component from hit actor using casting and a function called getComponentByClass. So we're going to wrap this in an if statement. We're going to do u primitive component prime component equals cast. Now casting is a way to convert one type to another. So we're going to be converting whatever get actor component returns to a primitive component. So we're going to cast to u primitive component, and what we're going to cast from is hit actor, and we're going to get component by class. And then what this takes in is a t subclass of then the component. So we want a u primitive component, and we're going to call static class, where people are being loud, call static class in order to actually get the what it's requesting the t subclass of from it. So if we have the primitive component and it's valid, We're going to do primitive component, set simulate physics, false. And that's how we're going to end up figuring this out. But first, let's check if we actually are simulating physics. So if, what was it, hit actor, hit root component is simulating physics. If it's simulating, we want to disable the simulation. Otherwise, we run through and we attach it. We are pretty much good to go here. I want to go ahead and move that line into where we set simulate physics to false and an else in here. So that way we don't try to attach it to the component if this fails. Let's give it a try. Control Alt F11 and try picking up this guy, which we did like so. So that's a physics object we picked up, and here's a non-physics object, which we also picked up. So we have that. Now we need to set up a way to dictate whether or not we can either pick up an object or drop what's in our hands. And when we drop it, we want to re-enable physics. So that's what we're going to be doing. First things first though, I want to go ahead and set this guy to simulate physics once again and save. So, now that this is taken care of, we will work on that in the next video. So if you like what I'm doing and you want to help support me, there's a link to my Patreon in the description. And if you have any questions or anything like that, feel free to join my Discord and I'll help you the best I can, or somebody else will. I'll see you in the next video.